Okay, so please tell me about yourself.
Yeah, hi, and I have around 4 years of experience in Java development, and my main skills are like in core Java, Spring Boot, microservices architecture. So actually, my skill mostly focuses on the development of RESTful web services. So I am comfortable working in full stack environment as well, and my core strength is the backend development. And in most recent project, I worked on the banking application where I was responsible for designing and implementing RESTful APIs using Spring Boot and microservices. So my role basically involved in ensuring the communication between the services like without any issues, and building secure, scalable and high performance APIs. And I also played the key role in API testing to ensure the endpoints were functioning as expected. So mostly I have used Postman and JUnit. So JUnit to writing the test cases and all, and Postman for the testing the APIs. So yeah, so these are the tech stacks I have worked on, and this is about myself.
So you have used only JUnit. Have you used Mockito as well?
Yeah, I have worked on Makito as well. Yes.
Okay, okay. And what about the database? Which database you have used?
I have used relational databases like MySQL.
Okay, MySQL. Okay. Okay, so let's start with Java. What is the latest version of Java you are working on right now?
Yeah, recently we have migrated from Java 8 to Java 17. So Java 17 is the latest version we are using.
So, while migrating, what are the challenges did you face? Or did you face any challenge?
Yeah, actually we faced a few major challenges. We earlier we were using JAX-B and Java FX. But after Java 8, so it has been removed. So earlier we were using that for the XML binding. So I had to manually add the dependency or find the alternative library. Uh, so that should be working with Java 17. So that is one. And then we did not face the major challenges, but yeah, we obviously we have Maven, and also that build tools we need to update according to like the target version to Java 17 and other related configurations. So after upgradation, so right now we are into the testing phase. So we are testing and validating like each and every module after updating. So yeah.
Okay. Okay, so do you know any new features of Java 17?
New features, yeah, pattern matching is there. So with switch statement now, we can use the pattern matching. So that makes code the more readable. So it basically simplifies the way we handle multiple conditions in the switch statement. And then that sun data star package has been removed. So now any code that was relying on the internal APIs like uh, the sun data stars or internal methods, so that will be forced to like um, that won't be able to use that anymore, and we have to use some public APIs or third-party libraries in order to get the same outcome. And then applets, which earlier we were using, so that has been removed now. And also some improvements related to the garbage collection also has been done. So yeah, so these are the improvements are there.
Okay. So you talked about applets, right? So can you tell me why applets has been removed now?
Uh, Applets were like kind of the UI thing, which we could have done earlier using Java, but now I think those has been removed because um, now there are various good technologies or better technologies are there than that, like HTML5 we have, JavaScript is there, so those things are much better and widely used than those applets. So that's the reason I think why that is deprecated.
Okay. So that is deprecated or that is removed?
No, that is removed, sorry.
Mhm. Okay. Okay. So what are the four pillars of OOPS in Java?
uh, you mean object oriented programming?
Yes.
Yeah, so we have encapsulation, then inheritance, then polymorphism is there, then abstraction is there. Yeah,
What is encapsulation?
yeah. Encapsulation is basically the bundling of the data or fields we can say and methods. So when they operate together on the data in as a single unit, then we say this as encapsulation, and it also hides the internal details of the object, and for that we make the whatever the fields are there of a class, so that we make as a private, and then we can give the public getters and setters to access that specific field. So yeah, so that's what is the encapsulation.
Okay. So tell me one thing. So in our DTO class, as you said, we have the fields and we have the getters and setters, right? So we make the fields as private and getters and setters as public. So why we do that? So why can't we use the fields as public and without getters and setters?
Yeah, basically we don't do that because the major problem is like without getters and setters, like whenever suppose any kind of checks we are doing before modifying the field, so that we cannot do if the field is public and it is directly accessible. If so, for example, let's say any class is there or any person class is there, and it has a field called age, and age cannot be the negative numbers, right? So whenever in the set age, whenever usually we write, so we can write there the condition, if condition, like if age is greater than 0 then only set, but if it will be public then we can set the age directly. Okay, so that is basically the not the correct thing, right? And then another reason is like whenever we use getters and setters, so it basically provides more flexibility uh, to the user. So whenever we use getters and setters, it allows us to change the implementation without affecting the rest of the code that uses that class. Okay. So if we directly access public fields, so the changing the internal representation might require us to refactor the code in multiple places. Okay. So yeah, so that's the reason why we should not use fields as public.
Okay, so can we override private or static methods in Java?
A private method, no, it cannot be overridden. So private method, since it is only accessible within the same class, so it cannot be visible to subclasses. So yeah, we cannot override it. But coming to static methods, so that also cannot be overridden in normally. Uh, but static methods are basically the class level methods, so that is not the instance level. So if a subclass defines a method with the same signature, then it is known as method hiding, not overriding. It looks like it is overriding, but it is method hiding actually. So yeah, so in that sense it can be done, but otherwise it cannot be done.
Okay. Okay, so what is the difference between interface and abstract?
Interface basically provides some set of methods, but this method won't be having any kind of implementation. So whatever the class is implementing that interface, that need to override all those methods. But in case of abstract class, so they can provide both abstract methods as well as the concrete methods. So abstract methods basically means they will have no body. So it is like similar to interfaces, but it can also have the methods with the implementation. So whichever class is extending that, so they can use those methods, or further they can write the implementation of the those methods. So yeah, this is the difference.
Okay, can you share any real-time example like when to use interfaces and when we can go for the abstract one?
Yeah, sure. So let's say for example we have any messaging system. Okay, so suppose we are building a messaging system that sends different types of notification to users. So let's say like SMS is there, email is there, or let's say push notification is there. So suppose we might have the scenario like we want to send the message without specifying any behavior for how the message should be sent. So each message type will have its own implementation. Okay, so uh, in that case we can use interface, right? But we will have those set of methods, like common set of methods will be there. Okay, so this is a scenario for the interface. Okay, but suppose if you want to share the common functionality, suppose the formatting of the message and adding a timestamp or logging the delivery, so among the different message types. So if that kind of situation is there, so in this case basically few might be the same thing, common thing like formatting and all, but still we have the sending mechanism is like different. We have the different implementation for all. Okay, so in that case we can go for the abstract class.
Okay, so are you aware about the collections?
Yeah, collections is a way of programming which has like a set of data structures. So it basically has list interfaces there. It has set, it has map. So yeah, so these are the major ones.
Okay,
So further this this list has again array list, linked list is there, and then set we have has set, linked has set, reset is there. We have queue as well. So in queue we have linked list, like priority queue is there, and then we have map, hash map, tree map, linked hash map.
okay. So are you aware about concurrent hash map?
Yeah, concurrent hash map I am aware of. Like it is basically the we can say thread safe implementation of the map interface. So this basically allows concurrent reads and writes by multiple threads without locking the entire map. So it basically locks only the specific segment or bucket. So basically, whatever the map we have, hash map we have, that has initially like 16 buckets are there, and by the time it grows, so those buckets also grows, and whenever like uh, read write operation happens, so it allows lock on only in a specific bucket, so it does not throw the concurrent modification exception. So yeah.
Okay. And what is the scenario when you have used this?
Scenario, let's say we have our web application, so that stores user profiles data, and that is frequently accessed by many users, and we want to cache these profiles in a map, but we need to ensure that the cache is thread safe to handle the multiple concurrent requests. Okay, so suppose a user requests their profile, but if the profile is not cached, then we need to fetch it from the database. And if multiple threads are trying to fetch the same user profile simultaneously, then the system should not perform the like continuous database queries, right? So in this case, basically, we can go for this concurrent hash map.
Okay. Okay, so what is the difference between array list and linked list? And in which scenario we should go for which one?
Yeah, these both are the part of list interface only, but array list basically we use whenever our main objective is to just fetch the data. But suppose our main objective is to insert the data or delete the data, so in that case we go for the linked list, because the underlying data structure of the linked list is the doubly linked list. Okay, so like we whenever we have to insert any node to that between the, let's say, two nodes, so in that case we can simply break the connections between them and we can simply insert it, so that is much more easier than the array list. So, and if we want to insert the data to array list, so in that case it will shift each node one by one, right, and then only the new node can be added.
Okay, so do you know the internal working of hash map?
Yeah, I know that.
Okay, so can you tell me, so before Java 8 and after Java 8, what was the change introduced in the internal working of hash map?
Yeah, the change is the introduction of the red black tree. So before Java 8, so whenever like we used to add the um, suppose any item we are adding to the map, so that has to go to the some bucket, right? So suppose that bucket already has the data, so in that case it will be keep on growing and keep on adding the nodes to that bucket. Okay, so earlier so it will be keep on adding and it will be as it is, like any new node will be the attached to the previous node and so on. But in Java 8 onwards, so we have a red black tree, so whenever this size grows to more than or equal to 8, so it automatically converts to red black tree. So because of that, the traversing is much faster, and quickly we can fetch and like whenever we say put or whatever get operations will be much faster than the previous one. So that's the difference.
Okay, so what are the lambda expressions in Java 8?
Yeah, so lambda expression basically it provides a way to pass behavior as a parameter, and it enables a more functional way of programming. So suppose we have any functional interface and that has any like single method. So instead of writing the whole interface name and method name, so we can use the lambda expression. So for that, basically, we use a list of parameters. So if suppose any functional interface is there and that has one method, so we can simply write with the arrow sign is there after that parameters, and then we can write the whole body, whatever the expression we want to write in the body, we can write that. So that's the lambda expression basically.
Okay. So can you tell me what are the inbuilt functional interfaces in Java 8?
Yeah, we have runnable comparator function is there, uh, predicate is there, and then consumer supplier. So yeah, see, all these comes under functional interface.
Okay. Okay, so can you tell me what is Stream API in Java 8 and how it is different from the traditional way of collection?
Yeah, Stream API basically is it allows processing sequence of elements in a functional style. So here the main difference is that the on top of a stream we can either stream the data normal way, or we can also do into the parallel way.
Okay, what do you mean by normal way?
A normal way means the sequentially. Yeah, so see, it can be either sequentially or it can be either parallelly. Okay, and then collections basically they are for to store the data, but streams are used to process the data. Okay, so this is the major difference, and also collections are mutable and streams are immutable. So that is also one difference.
Okay, so can we reuse the stream?
Reuse,
Okay, so let's say you have list, okay, and on that list you say list dot stream and you keep that to some, it's a one variable, you keep that to one variable, okay. Now you say that variable name as a stream, okay. Now on that stream you say for each and you just print everything, getting me? Now suppose we are trying to again stream dot for each and we are trying to print it, okay. So will it work?
uh, yeah, the first time it will work. First time when we say stream dot for each, and whenever we are printing it, it will work. But next time again on the same stream, if we are trying to do for each, it will throw exception. So we cannot do that.
Okay, okay, fine. Okay, what is the difference between for each and for each ordered? Do you know?
Yeah, for both for each and for each ordered are used to iterate over elements in a collection or a stream, but they are different. So, like for each method performs an action for each element of the stream, but it does not guarantees the order. Okay, in parallel stream basically. So, in a sequential stream, it behaves same as the for each ordered actually. Okay, but whenever we are using for each order, so this method is used when we need to guarantee the encounter order of elements in parallel stream. So it ensures the action is applied in the same order as the elements appear in the stream. So in that case, we use a for each ordered.
Okay, can you explain what is microservices and its advantages over monolithic architecture?
Yeah, microservices it breaks down the application into smaller independent services, and that can be deployed and scaled individually. So in so whenever we have this monolithic architecture, so there we have the entire application is tightly coupled, and microservices allow for more flexible scaling and easier maintenance. Okay, so if in microservice, if one service fails in a microservice architecture, then the other service can still function independently. So in microservice, if one microservice fails, but it will not take down the whole application. Okay, so only that specific portion will not be working. So that's the advantages basically.
So, do you know Saga design pattern?
Yeah, Saga design pattern is used for managing distributed transactions in the microservices. So it basically ensures that if one service fails, then the entire transaction will be rolled back. Okay. So for example, let's say uh, in a banking scenario, when the service A sends the transaction request to service B, and if service B fails, then service A's transaction will also be rolled back. Okay, so that will basically not let happen the data inconsistency. Okay, so the pattern can be implemented with so there are two types of this. One is orchestration or choreography. So in orchestration, that involves the central controller, and choreography involves the services communicating directly. So that's the difference between these two.
Okay. Okay, suppose you have to create the Spring Boot application from scratch. Okay, so how do you do that?
Yeah, so we basically do it mostly two ways. So one is the Spring IO up URL is there, right? So there we can specify necessary project details like group, artifact ID, and all, and we can also give its dependencies like Spring Web, JPA, and we can select Maven or Gradle as the build tool, and it will basically generate the project for us. And then coming to STS, so STS chooses we can choose like new Spring starter project, and we can follow the prompts whatever comes on the screen, and we can select the dependencies or the project structure. So this way also we can generate it. Yeah.
Okay, okay, fine. So, what is the role of circuit breaker in microservices?
Yeah, circuit breaker is a design pattern basically that is used to prevent system overloading when the any service is down, or if it is not responding. In that case, we can use the circuit breaker. So if the service is unavailable, then the circuit breaker trips and it prevents further calls to the failing service, and it allows the system to maintain its functionality. Okay, so a fallback method we can invoke. So it will retry the failed operation, or it will provide the uh, default values for that.
Okay, okay. So, what is dispatcher servlet in Spring MVC? Do you know?
Yeah, dispatcher servlet, like it is a central component in the Spring MVC architecture, and it acts as a front controller for handling HTTP requests. So when a request is made, so it first reaches to the dispatcher servlet, and the servlet uses the handler mapping to find the appropriate controller, and then it forwards the request to the to the next, and the controller processes the request and returns the response. So which further dispatcher service renders using the view resolver. So that's what is the dispatcher servlet is.
Okay. Okay, so you know SQL as well, right? So, what is the purpose of using views in SQL?
Yeah, a view in SQL is a virtual table, we can say, that provides a way to simplify the complex queries. It is basically used to store the query that can be treated as a table. Okay. So the underlying to that view, whenever we will open that, we can see the underlying queries there. So it allows us to reuse the complex select queries without writing them repeatedly. Okay. Uh, so that's the use of the views. So we don't have to write every time the complex queries to fetch the data. So yeah.
Okay, okay. So, what are the types of joins in SQL?
Yeah, so basically there are mainly four types of joins. Mainly. So one is the inner join, then we have left outer join and right outer join, then full outer join. So these are the joins we have. So this inner join basically it returns the record that have the matching values in both of the tables, and similarly like left join will return all records from the left table and only the matching records from the right table, and right will do the vice versa, like matching all the records from the right table but only the matching records from the left table, and full outer join will return all the records uh, like uh, when there is a match in either of the left or right table. So that's the difference in these joins.